Vinay is a senior security engineer with Salesforce, and Lakshmi is a security researcher with Adobe. They've both been pretty integral in putting together bug bounty programs within their respective organizations, and they're going to bring some of those insights here. So please help me welcoming Vinay and Lakshmi.
Thank you. Thank you everyone for joining. We'll be speaking about a tool we built for the bug bounty community, which we'll be open sourcing today, called ReproNow. It helps you save time reproducing and triaging security bugs. So a quick introduction about ourselves. I'm Vinay Nataraja. I work as a senior product security engineer at Salesforce. I help build secure products, and I also run their bug bounty program.
So I'm Lakshmi Sudhir, and I'm currently a security researcher at Adobe. I was previously working with Zenefits, where I concentrated a lot of my efforts on their bug bounty program. And when I would meet Vinay and we would just discuss about some of the issues we face in bug bounty programs, we realized that if we are facing it, a lot of people in other organizations are also facing the same things. And that's how we came up with our tool, ReproNow. So let's get right into the talk. The agenda for today. So we're going to start off with a basic understanding of the bug bounty program. How many of you here have been a part of, have run a bug bounty program or submitted a bug? Okay, that's a great number. For the rest of you, it's a brief introduction. That's about it. Then we're going to walk you through the triaging process. How much effort does it take for a security engineer to take a bug that has been submitted onto the process where it's valid, it's verified valid, and you can triage it, create an internal ticket, and resolve it. Then we're going to walk you through how can ReproNow help with the problem statement. Further, we're going to look into how did we build the tool, what are the technicalities in it, and if the demo gods are kind to us today, we're going to have a successful demo. Also, we're going to discuss the future plans as to how can we enhance this tool further, what we have planned, and also can these results actually be fed into other tools that can be used in organizations. So let's get into what is a bug bounty program. A bug bounty program is nothing but crowdsourcing security. We have a lot of security researchers all over the world. So this platform gives an opportunity for companies to connect with all these researchers beyond geographical borders and leverage their intelligence. So when a researcher submits a bug, so a company basically provides a platform for all these researchers to look into their application and submit security bugs. Then the company validates all of these bugs and pays a bounty. So for a company, they're leveraging the intelligence of so many researchers all over the world. And for the bug bounty hunters, it's pretty good to connect with the security community, hone their skills, and get some reputation in the community. Also, I've met a couple of bug bounty hunters or researchers who have made this a full-time profession. So that's a pretty good win-win situation for both the organization as well as the security engineers, researchers who are looking for bugs. So let's say your organization wants to set up a bug bounty program. How do they start off? So they have to have a structured approach towards creating the scope for the program. You would want to define what product are you comfortable for researchers to go ahead and test. You cannot have this as your first line of security testing, of course, because you would want a mature product to go out there after you test it, because you're opening it to the world. Then you're going to define, if it's a web application, some of the domains that you're comfortable sharing with, and like you're okay with the researchers looking into it. You wouldn't want to have your revenue or payroll system out there. And then the most important thing what I see is setting your rules right. When you don't want a researcher to touch a particular vulnerability, for example, you don't want someone reporting a denial of service on your production. I mean, you don't want them testing for denial of service and bringing all your production servers down. That's a nightmare every security engineer can think of. Also, you may want to specify something a little milder, like let's say you have CSP, which is still being implemented. It's in the pipeline. And you do want a bug bounty hunter to say, hey, you guys have not implemented CSP, and you don't want to waste your time like communicating to each hacker that this is something that's in the pipeline. So you may want to put all of these in the rules. And you may not accept certain class of bugs as well. And after this is done, you provide credentials, or you provide a way for all of these researchers to set up an account and start looking into your application. Then the security researcher, he submits a bug, and the engineer, you have a couple of people on call, or you have some people who manages bug bounty itself, and they validate this bug, they look into it, and they resolve it, and the company awards the researcher bounty. This is how it would work. So let's look at a little more in detail about what happens when a researcher submits a bug. So we have a researcher who submits a security bug, all great right now. Then the security engineer triages this. Now triage. Triage would involve looking into this bug and understanding the description of it, the impact of it, and also reproducing the entire bug and confirming the validity of this bug. Then further, the security engineer, once, let's say, the bug is valid, he creates an internal ticket with whatever Jira or any of the logging systems you have, and the developer agrees to fix it. So that is what is the triaging part of it. So in this case, he triages it. That's good, going still well. The company resolves the bug, amazing. The security posture of the company increased, got a little more strengthened, one bug more. And then the researcher's awarded bounty, the researcher's happy and is looking into your app some more. Wish things were this ideal. So this is just the expectation of it. Let's look at what happens in reality. So researcher submits a bug, everything's great. The security engineer tries to triage this, but he requires more info. It's not just simple with just some steps to reproduce. So he asks the researcher saying, I need some more info. Can you provide me with a little more information about this? So the researcher provides some requests. Let's say he sends out some, oh, this was the post request I used, and these are some of the screenshots that could help you. Or maybe this is the parameter that you may want to modify with this account. We believe that this should be triaged now, but unfortunately in reality it doesn't. The security engineer requests for more information, then probably just a POC video of walk me through this. And the researcher provides a video, and only in some times that within two interactions that the bugs get resolved, but otherwise this goes on. It's a vicious cycle, and it takes a long time going back and forth to reproduce and finally get to a stage where it's triaged. So let's look at what information a security engineer would need to actually triage a bug. To start with, you need to know what product the bug is on, of course, and then you need to know the URL if it's a web application. You need to know the impact description. What is the researcher defining out here? What is he trying to get to? Of course, the steps to reproduce. For the steps to reproduce, you would require a lot of information because everything is complex today. And the bugs are not simple always. So you need to probably have some of these HTTP requests, a post or get request, wherever the bug is. You need some screenshots. You need to know the flow of it. You need to know the pre-existing conditions. While this is not an exhaustive list, we've listed some of the main things, but you require way more information most of the times. So let's look at some of the sample reports we have. We pulled all of these reports from HackerOne's activity. It's all real bugs submitted by researchers to organizations. So the first one out here, the researcher submits a bug. He says there is some vulnerability. He gives a summary of it, and then he's even given some steps to reproduce. There's more in the steps to reproduce. I've just kept the main ones for the context of this. And the security engineer changes the state to needs more information. He's not able to reproduce this. He thinks probably there was a fix that went on for something else, and this might have fixed it. The researcher comes back with, no, you may want to use my account ID, which is another piece of information he shared out here. Now we think it should be triaged, but well, no, it still doesn't. And he says, I'm so sorry, but could you provide me with a POC video? I'm sure the researcher would have been a little like, oh my God, I find this bug and I have to give so much information out here. But he would do it anyway because he's also trying to be a white hat and trying to help a company find a bug. Then he provides a POC video. There's been more back and forth. And like I said, I'm just keeping some of the conversations for context here. And then boom, it gets triaged. So finally, we have a security bug getting triaged. It takes a lot of time from it being submitted to getting triaged. Let's look at another report. Here, a researcher submits a report to a company and he says there's a weird misconfiguration. There was a huge POC he had provided as well. Then the security engineer thinks that this is not a bug. He closes this bug and says it's not applicable, giving his own reasoning out here. The researcher is a little frustrated. There was a lot of back and forth that went where he is trying to communicate what exactly is the issue here and trying to make the security engineer get his point of view. And finally, the researcher is so frustrated in this comment out here. He's like, I'm disappointed with the program, but this is my last go at it. And he provides a proof of concept. And then the security engineer understands. He reopens it from closed and not applicable and gets it to triaged. Well, there's no mistake of anyone out here in this scenario. It's just that things are so complex and it takes so much time. The communication out here is so hard. And even if one of them had given up at a point, losing their patience, a security bug would have been lost for the organization, and the researcher would also lose interest in a program and belief in the whole system. So oh yeah, sometimes you also have bugs like this, where he says, I'm going to copy my cookies and paste it in another browser and I'm logged into your site. You get spam reports like these as well, and I wouldn't want to go about explaining how web works to all of them out here. So triaging also involves weeding out these kind of reports and not losing the relationship or your reputation in the program. It's a little trivial sometimes. So let's talk about what are the triaging issues categorized. So the biggest thing, as we saw here in bold, is communication issues. Bug bounty program is nothing but crowdsourcing security. So like I said before, you have security researchers all over the world. While their technical expertise is amazing, I don't understand French and they might not know English. So the language barrier always comes into play while showing a report or writing a report. It's a pretty big issue that we face. Also, I could agree that knowledge gap of product is an expected outcome of opening a program, because let's say I'm in Adobe right now and I wouldn't know all the products that Adobe does. Trust me, there's so many times I get to know it in a very different way. So none of us would know all the products inside out, and that also causes, that could be, you could have a reason to not have one of the best practice out there because of a business case scenario, how your product should work, and the researcher may not know about it. So that's also one of the things that causes a triaging issue. Also, I, out of all people, should agree that not everyone can write a good report. Finding something is amazing, but writing a good report, that's a different ballgame out there. So that's also one of the issues. So moving on, complex workflows and long reports. We all live in this technical or really complex ecosystem where you have applications interacting with another application, and there's so much communication that goes back and forth. And when you find a vulnerability which can occur only in a particular condition when certain interactions occur, it's pretty hard to put all of them in a report. I myself have spent, even if a researcher has all the patience to get this all in a huge report, as a security engineer, I remember one or two instances where I've spent the whole day trying to understand this, reproduce the whole conditions, and get there. And since I've been there, if someone had said that to me, I would be like, oh, probably that's exaggeration. But no, I've been there and I've spent like 7 to 8 hours with another security engineer trying to reproduce some of the awesome bugs that we get. So this also adds to a lot of time that takes with respect to triaging. And like I showed the previous report, there are a lot of wannabe hackers. Sometimes they fling bugs from like other programs. Let's say there's a bug that's floating around like subdomain takeover or something. They just put the same thing out there, submit the same bug, and you'll have to weed that out. So what do companies face? What are the pain points for all the companies out there? The first thing, as we all can agree, time is money. And when you're hosting a bug bounty program with an idea of getting good reports and strengthening your security posture, the last thing you want to do is having your awesome security engineers just spend time reproducing all these bugs over and over again, going back and forth. This is something that none of us want. Also, this decreases the efficiency of having a whole bug bounty program. You could have your security engineers spend some time reproducing and validating this and doing other cool stuff, either breaking in or building awesome stuff. So that's the main pain out there. Also, with respect to bug bounty, resolution time is a very important metric. So as a researcher, when they look into a program and they say, I submit a bug, it is getting resolved after 3 months, then that's not a program that as a bug bounty hunter, I would be interested in. So this plays a huge role. And if there's a lot of back and forth, it increases your resolution time for no fault of anybody. And that causes, of course, researcher retention becomes an issue, and you don't have all the researchers there leaving your program because of all these communication issues and triaging issues, and you wouldn't want to get there. This quote from Colin Green of Facebook pretty much explains what I was trying to get to. Triage takes time, and a lot of time. A lot of organizations have about 2 or 3 people full-time just to triage and reproduce these bugs, because going back and forth, understanding this vulnerability and getting to the depth of it takes so much time. And that's when we thought, this needs to be improved. I mean, we need to make this more efficient. There should be a way out. And that's how we came up with our tool, ReproNow. So what is ReproNow? When I will take it from here.
Thanks, Lakshmi, for the wonderful introduction. So as you saw, there's a lot of back and forth with the security engineer and the researcher. We wanted to build a tool which saves the time and also make it more efficient. That's why we built a browser extension which not only captures your desktop, but also the network. So security researcher can install this, go through his vulnerability. It records the screen as well as the network interaction that happened during the recording. We then give an option for the security researcher to preview it and then view and search for anything he wants to. And we also have an export functionality where you can export the captured video. We make sure that we put the network request inside the video in an MKV file. We have built the tool using the extensibility API. It's a cross-browser tool. It works right now in Chrome and Opera. We are working with the Firefox team because they have to implement one of the extensibility API, and once that's done, we'll be having it support for Firefox as well. The tool doesn't have any servers. Everything is on the client. It's a JavaScript application, so you can might as well put it on your own machine and then run it. We have ability for you to export as curl request. Sometimes when you're submitting a bug bounty bug, the security engineer asks for a curl request. So we have ability for you to do that as well. And you can use this to export to burp. We also store all your recordings in the local history. So let's say you have recorded something 3 weeks back and you want to go back to and check what happened in the network, you could do that as well. We have multiple options for you to capture network. We're going to talk about this in the future slide. Most importantly, everything is open source. So if you want to take a look at the code and if you want to add more functionality to it, you are open to do so. So how does it work? There are three main aspects to this whole application. There's the screen capture, for which we use the get user media API. The network capture, we use the web request API. And hiding the network data inside the video itself, we use the MKV files. Let's dig into each one of these. For the screen capture, so if you are building a Chrome application or any other browser application, if you want to capture the screen, you could use the Chrome.desktop capture API, which in turn uses get user media API. Get user media API is the HTML5 API to capture your screen, mic, or also camera. In our case, we'll be just capturing the screen. Once you have the whole stream, you then pass it to a media recorder API, which then converts it to array buffer, which you can use it in the video tag. So let's dig in deep for the media recorder API. So media recorder API supports multiple MIME types. In our case, we are using WebM. It also supports multiple codecs. We are using VP8. This is not an exhaustive list, but this are some of the codecs and some of the MIME types that it supports. So once we use the media recorder API, we can convert that to a video tag by using the create object URL API. And once you have the video tag, you can pause and play and do whatever you want. So let's look at the code for the screen capture part of it. So as I told, we use the desktop capture API. We pass in some parameters, and we have a callback function on access approved. So when the user approves the access, the callback function gets called, which in turn calls this webkit get user media API, which is same as get user media API. We pass in some parameters telling we want the desktop, we want this is the size, and this is the width, this is the height, and it has a callback function for got stream. So got stream is when the stream is being fetched, that function will be called. So got stream will, we then set the stream as a global variable and then pass it to the media recorder API. Media recorder API get the stream and also the options, so which in the case is the MIME type and the codec. And we also have a callback function for that, that's the handle data available. The handle data available will have all the data in an array buffer format. We then push it to an array and then pipe it to a video tag using a create object URL API. So that's screen. Let's move on to the network part of it. So if you want to capture network in a browser extension, you have two ways to go about that. You have the Chrome.debugger API and the Chrome.webRequest API. Chrome.debugger API just attaches a debugger to all the tabs and then intercepts traffic. The only problem with the debugger API is that it puts all the tabs in a debugger mode. That means you're going to see a big bar at the top telling that you're in a debugger mode, which is not a good experience since we are capturing the screen as well. The other one is the Chrome.webRequest API. WebRequest API lets you observe, analyze, and also modify request in flight. We do not need to modify it, we just need to log the request. That's why we went and used Chrome and used WebRequest API. The only problem with WebRequest API is that it cannot fetch the response body. That's okay for us because all we need is the URL and the get body and the request body and the response headers. So let's dig in deep for the Chrome Web Request API. We won't be going into each one of these, but for the request part of the communication, these are some of the methods that are supported. And for the response, the first 4 methods are supported. And if the communication is completed, on completed method is supported. And if some error occurred, you can call the on error method. For this, for our particular case, we use these 3 methods. That's on before request to get the URL method and the request body. On before send headers to get all the request headers. After this, the request is sent to the server, and the server responds with a response, and that will be calling the on headers received. The on headers received will have all the headers. One more thing to the network is we need to sync the screen that we captured and also the network. So we kind of make sure that we start a clock at the same time, and then once we have everything as a JSON, we then pass through and make sure when the screen is played, we sync the network as well. We also have multiple options for you to capture network. For example, let's say you have multiple tabs open in a window. You want to capture a specific tab. You can do that. You can capture network of all the tabs in the particular window. You could also capture, let's say you have 10 tabs open and you're going from tab 1 to tab 2 to tab 3, and you want to capture only the navigated tabs, you can do that. Or if you want to capture only the active most tab, let's say you're going from tab 1 to tab 2 to tab 3, but you want to capture the active most tab, you can do that as well. So you have multiple options. We have all this explained in our GitHub page, so you feel free to go and take a look at it. So let's look at the code for the network capture. So network capture, as I told, we use the web request API on before request. We add an event listener, and there's a callback function called add web request. And there's multiple options for it that you can pass. And in the callback function, we get the details, which we then store it in a JSON, which we use it later. So now we have the screen and the network. As I told, we have export functionality as well, where we can export the video and we hide the network inside it. So Lakshmi is going to explain how that works.
Thank you, Vinay. So we have the screen data as video and the network data as JSON right now. The next thing we thought was, how do we share this with the engineer or the security researcher? How do we share it across each other? The first start, as being just us and lazy, was that we can just have this JSON and video file downloaded separately. They could upload it in our previewer and view it if they want the network data and the screen data like side by side. And if they want to use a third-party player, of course, they have the video file. But this is a little cumbersome. And we thought, why not zip it up? But again, that was a lazy solution. So we thought, why not have this network file inside the video file and make it one, without breaking the video, of course. So if you want to view it in VLC player or something with just the UI, you could go ahead and do it with a single file. And if you upload it to our previewer, then you can see both the network data as well as the screen data together. So we thought, okay, let's look into this. And one of the main things for us was we didn't want anything on the server side, even the manipulation or the video, nothing on the server side. We wanted everything to be on the client side. So what do we require for this? We require one of the video formats which support adding a JSON file, and it should not break the video. We still want it to be played on a normal third-party player. And then we wanted an API tool, framework, library, something to perform a client-side operation to manipulate this video file, like encoding, attaching, and decoding, and all of those operations to happen on the client side. So let's explore the first aspect of it, which is finding a video format which supports adding a file as an attachment. So we looked into the most common video formats. We looked at MP4, we looked at MKV, we looked at Flash and AVI. For the talk today, we're going to focus just on MP4 and MKV. So we started off looking at MP4. And as we all know, it's a digital multimedia container. It stores audio, videos, and stuff, subtitles, all images, and everything that a container has to do. One of the issues we found with this is it's a licensed one. It's not a free format container. So getting a lot of data, be it about the structure or any information, and then using it would be a little complicated. We further explore the structure a little, so you have a lot of granular details, but you have the file type, which would be MP4 in this case. Then you have the move container, which contains the whole metadata for the song, the URL, the title, the subtitles. And then you have the actual audio and video streams stored in that multiplexed data container. So if we had to insert a file, we should have found a way to manipulate the move part of it, the metadata part of it, that block. We had to insert it there. We thought that's fine. I mean, this is a little complex, so let's go ahead and explore MKV. We started off looking at this. It's a free container format. Yay, that's a good point to start with. And then we found out that it holds unlimited audio tracks, video tracks, subtitles, and files as well. Also, one of the most interesting things we found was WebM was derived out of MKV, and it was specifically created to actually use on browsers, so used on the internet mostly. So we found that that's a pretty good thing for us having, because we wanted everything on the client side. So we further went into the structure. Yes, it has the header. There are a lot of details out there. The EBML version would be MKV for this. Then you have the metaseq information, which indexes every aspect of the whole container, like the track information chapters and attachments as well. And the clusters is where you have the audio and video streams. So as we've been pointing from the previous slide, attachment is what we were interested in. We dug a little deeper, and it could hold any file type. And all we had to give was the file name and the file data. That's about it. And the MIME type, we had to specify the MIME type. So we were like, this is pretty cool. I mean, there's no restriction on the file type in the attachment section. And again, WebM is built on MKV, so we mess up some of the codecs or something, we can use WebM and this MKV interchangeably. Also, all browsers, most browsers support WebM and MKV. One more aspect was this was pretty easy to store and dump a JSON file, so that you wanted to store it because when someone downloads it and shares it to the security engineer, you want it like within the MKV file, and dump it is when we want to pass for the network data so that we get the beautiful display out there for everyone. Let's look at how we did that. So we have our video format all set. The second thing was API tool framework, something to perform all this on the client side, which was a challenge. That's when we looked at FFmpeg, which is the mother of all multimedia framework, because it manipulates any kind of audio or video file. It supports a lot of codecs, like more than 200 video and audio codecs, and we just required it for one. So it encodes, decodes, marks as ZMA. It performs all manipulations in short. So when we were looking at it, we wanted a JS version of it. We found the ffmpeg.js, which can run on a browser, amazing, everything. All the manipulation happens on the client side. So this is just a small code snippet of how it works on the server side, but we've implemented this for the client side as well. So we just input the screen data, which is video.mkv here. Then we attach it, with our JSON, which has our network data. Then I'm just specifying the MIME type, which is JSON here, of course, because we are adding the JSON file to the MKV. And the output.mkv contains both the screen data and the network data. You can play this in a VLC player or any third-party player. It doesn't break it. And if you upload it to our previewer, we get the JSON out, and we have the network data and the screen data, whatever we wanted to capture, all together in a single file. One of the things we didn't like about ffmpeg.js, the caveat was that it's a little slow because it supports so many audio and video codecs. It has so much out there. It was a little slower than we wished it wouldn't have been. So that's when we found this Node.js library called tsebml, which encodes and decodes MKV files. While this does not support all the formats, it made things work. So we have a loop where it first kicks in tsebml, and then if that doesn't work, it falls back on ffmpeg.js. So we implemented both so that reliably we have a client-side manipulation of the file to get the network data and the screen data together. So let's put all of this together. First, we record the screen using the get user media API. Then we capture the network using the web request API. We store the screen data as a video and the captured network data as a JSON. Then we save this video and JSON in your local storage. It doesn't touch a server anywhere. Then we preview it using the HTML5 video tag. We, of course, sync this network with screen when we preview it. And if you want to download it as a bug bounty hunter and pass it on to a security engineer, we are attaching the network data to the screen data and give you a single video file that can play in which doesn't break the video. And you can play it on a VLC player, or the security engineer, if he wants to look at the network data and the communication as well, he can upload it to our previewer. So Vinay will now show you the demo of how this all works together.
Okay, so let's do a quick demo. Let me go to the most secure site in the world, demo.testfire.net. This is our tool. As you can see, we have the start recording button, which will, of course, start recording. There's a name. I'll give a name for this, AppSec Live Demo. And as described, these are the options. So in this case, I will just choose the active tabs and the navigated tabs. There's also a history section. You can go and look at the videos that you have already recorded and then play this back. Yeah, so let me go and start the recording. Let's imagine I'm a security researcher. I'm trying to find a bug in demo.testfire.net, and I want to report this to the bug bounty. So let me start the recording. I'll try to find a place where I can find an SQL injection. So let me go to the feedback page. This looks good, maybe not. Contact us, there's nothing much here. Let me go to the sign-in page. This has a login page, which is awesome. Let me put a SQL injection payload here. And I'll give a dummy password, and I'll click login. Oh, there's an error. So yeah, I think I'll report this. So let me stop the recording. As you see, as soon as I stop the recording, there is a page for you to, in the left-hand side, you can see the video itself. The network interaction are on the right-hand side, and there's a request and response in the bottom. So when I start playing the video, it will sync the network data with the screen itself. So whenever I click the feedback, it showed the request and the response. And then I click contact us, it showed the request and response for the contact us. Now I'll go and put the payload, the SQL injection payload. I'll put a password. I click save, and that's the interaction for the payload. So let me pause this. Let me look at one of the requests here. I'll look at this one. So as you can see, there's a header section which shows all the headers that are there in this particular request. There's a cookie section which has all the cookies, and there's all the body, and that's where we put the payload. And there's a response as well, 500 internal assert. I think this looks good. I'm going to go ahead and download this. So I click on download. It puts the network request inside an MKV file. Let me try and open that in a VLC player, and it just works without a problem. So, okay, let's say I'm a security engineer and I want to preview the video that was sent to me. You have two options. You can either install a Chrome extension, or you can go to our website, download the code from the GitHub page, and host it on your own on your own system. We have one of the pages as a previewer, which is open in the internet, so you can use this as well. So let me upload the video I just downloaded. Yep, and it's all there. You can do the same thing again. Also right now, I think the researcher has given me a payload. So I'll just search for the payload. I don't want to go with all the flow. So let me just search for the payload, 1 = 1, and boom, it just goes directly to the place where the payload was sent. And we have the request, header, cookie. I want to export this to burp. So let's check if my burp is open. I think everything is good with burp. I'll copy the curl request. Now I'll open my terminal. I'll paste it. I want to proxy this through burp. So -x 127.0.0.1 port 8080, and I'll ignore all certificate warnings. And yeah, let me go to my burp. The request has come through. I can send it to my repeater and do other manipulations and check if it's a bug or not. And that's how I triage this bug. So that's a quick demo of our tool. How is this useful? So if you're a bug bounty hunter and you want to use this tool, of course, it's a really good screen capture tool. It captures the network as well. You could preview your interactions before submitting it to a bug bounty program, so you exactly know what network went through and if the security engineer can triage it or not. We also have ability for you to copy paste raw requests and responses, and also generate curl script, as you saw in the demo. As you know, instead of writing a long explanation of what your POC is, you can actually generate a video and give it to the security person, because that will actually help you reproduce faster than explaining all the steps to reproduce. And also, there's no server involved. It's open source, so you're free to look at the code and add more functionality to it. Since there's no server, you do not need to trust a vendor. It's not going anywhere in the cloud, so that's fine. But most importantly, if you help your fellow security engineer to triage the bug faster, that means you get bounty faster, which is awesome. For organizations, you do not need to manually go through steps. Since you know about the product, you can directly go to the payload or directly go to the network request where this is happening and then triage your bug. This helps reduce noise as well. So if someone submits a report and you ask them to submit a ReproNow video, you can easily tell if it's a bug or not, depending on the network interactions. This saves your engineers, security engineers, time. I think the main reason we built this tool is so that it's easier for you to repro, which saves security engineers time as well as companies money as well. This tool can be used the tool is built for security, but can be used for QA internally. So feel free to share with your teams, and it's easy to kind of port it to a QA environment and test it there. Same as researchers, if you can triage faster and give bounty faster, they're going to come back to your program and submit more bugs, which will increase the security retention, and it's going to make your security posture more better, which is awesome. So there are a couple of things that we are thinking that we can do with ReproNow. One is automatically triaging security bugs. Since we have the network request, and let's say the environment you're given to the researchers is the production environment, that most of the time that's what happens. You want to replay that in internal builds and check if it is already fixed or not. You can do that because you have the network request, you just have to play it through the internal builds and check if it's a valid bug. And also you could check if it works across browsers. So let's say the researcher is only tested in Chrome. You want to check if it works in IE or not. You can do that automatically by automatically triaging the bug. One more thing that most of the companies do is automatically run ZAP on their internal builds. One of the main problems with ZAP is it doesn't do a good job of detecting the login page. And sometimes if it's an OAuth connection or maybe it's a XHR-based login, then ZAP doesn't do a good job of actually finding the login and generating session ID. You could use ReproNow to capture the request and then replay it and then feed the session ID to ZAP. So that's our tool. If you want to download the Chrome extension, that's the link, and this is the website you can go for. That's pretty much it. We are open for questions. Yep.
So yeah, I think it's a great job, and I really like what you've done here. Just thinking evilly, I just was wondering how you handle, first off, putting arbitrary files into a MPEG sounds really interesting. I'll put it that way. So I don't know if you've ever seen like malicious payloads from a researcher being submitted. And then secondly, when you said about like automatically, or even changing where it's doing internally when you replay it, what if I decide that I'm going to like embed some internal attacks, right? How would you defend against that? Because so I get a little bit leery of taking some binary with some JSON, right? How do I play that nicely in my environment without
Yeah, I mean, if you're really concerned about playing this video and that the whole payload could be malicious, you can of course open, this is a JavaScript file, there's nothing else. So you can open the video in like a VM and then try it out. But everything, whatever it's doing, it's just JavaScript. It's not, if someone has to attack you, they have to bypass the JavaScript and attack the browser and then come to you. And that's much more tougher to get to. They might be able to modify the request, but you're going to be replaying it and automatically checking if that's a valid bug or not. So even if they modify it, when you replay it, that's going to fail. And that way it's actually the network request or not. And everything happens on the browser. There's no server interaction. So even if they want to attack it, they can attack the browser. I mean, that's again same origin policy comes in place. So you can attack only a particular domain, which is not exactly a big target, right? Yep. Yep.
Yeah, very good idea. Just following on what this gentleman said about thinking maliciously, did I understand correctly that you can upload your output file to a website to preview it? Is that
Yes.
correct?
So
So whoever owns this web file with this website will get a preview of all the security bugs?
no,
No.
we don't store anything. It's all JavaScript. It's basically, if you go here, this is.
Oh, that's too bad.
Yeah, that's a good target, right? You didn't want any server interactions at all. So this is actually just a JavaScript file. You can download it to your desktop and then open it in a local host, and it just works fine. We just made it accessible in the web so that it's easier. But other than that, there's nothing to this. It's plain JavaScript.
Thank you.
Quick question. Great product, by the way.
Thank you.
Quick question, though. Is there any plans to add any kind of request manipulation tool or to be able to capture request manipulations along with the screenshots or along with the video?
What do you mean by request manipulation?
Let's assume we want to change a value, change a cookie, change something in the request, but we want it to come out in the video as well. Is there any plans to add something like that?
I think that's a good idea. We haven't thought of it. One of the things that we were thinking about is maybe doing like an automatic testing using the tool itself. But yeah, I think that's a nice idea. One more thing we were thinking about is cross tabs.
Yeah.
So if two logins are logged in different tabs and you have a
Log
privilege
windows.
escalation, then maybe you could reproduce that. But yeah, I think for this version, we are just sticking with the main ones, but we want to add more functionality, and that's a really good idea. Thank you for that.
Also to add, actually, you can capture the entire screen, not just the tab, the entire screen. So in case, for now, as a workaround, you can use burp and like just show what you did or something. But
Yeah, it'll capture the entire screen. The network is only limited
yeah,
to
the
Pro.
network, yeah, that would still be an issue. You're right, yeah. But that's a good idea, thank you. Yeah.
Hi. So it looks like you're capturing request bodies but not response bodies. Is
Yes.
that a limitation of the API or something that you're planning to do?
Yeah, that's, as I told in our slides, that whatever the,
Before that, I guess.
yes, right here. We are using the Chrome.web request API. The Chrome request API doesn't let you fetch response body. We could use a debugger API for that. I mean, honestly, we don't need the response body because we have to replay that again and check if it's a valid bug or not. If we have the response body, they can modify it and send it to us, which is not good. We want to replay that and check if that's valid bug or not. So the whole point of this is they'll give you the video and you can replay it, but it's not like automatically check the response body if the payload is there or not.
Okay. Yeah. Thank you.
Any other questions? Yep.
I got one more. I'm just wondering about a scenario where, I'd have to use my browser and then maybe private browsing mode so that I could emulate having two users. Will the extension happily record two separate browsers at the same time?
So that's the thing we were talking about. That's one of the things that it's right now it doesn't support. It just supports the browse, the web tab, a window you're in. It doesn't do a different thing, but we could put some functionality in, or maybe you could download two different videos and show it to them, but we don't have it supported right now.
Even as separate artifacts?
You mean separate windows?
So I have my regular browser logged into user A, and I have my private browser logged into user B.
Yep.
I carry out an attack over here. I see it over here. Can I record those as separate artifacts?
Yeah, you can do it separately. So you download 1 and 2, and then upload both the videos to them. But you can't combine both together.
Yeah, okay.
That's one of the things that we are thinking about, but we don't know how to implement it. But yeah, we have that in the pipeline, though. Yeah, I think that's pretty much it. We'll be here if you have any questions. Thank you for listening.
Thank you.